Hello everyone to this lecture about joint probabilities. So we say that two continuous random variables x and y are jointly continuous if there is a joint PDF noted by fxy such that for any subset B of the two-dimensional plane, so any subset B of the R2, there is the probability of x and y in B is the double integral for x and y in B of the joint PDF of x and y dx dy. So this is the probability of x and y in B, and it is called the joint probability, and we can get it from the joint PDF of x and y. In the case of the discrete random variables, the joint PMF, joint probability mass function of x and y, is defined by pxy equals px when x equals x and y when y equals y. And it is easier to express these probabilities in a tabular. So for example, when we have discrete random variables x and y that can take from the subsets 1 1 1 2 2 1 and 2 2. So let's just use this sample space to be easier for us to present them. So when we have x here and y here, so the value of y will be 1 and 2, and the value of x will be 1 and 2 also. So when we have 1 1 here, so for example if the probability is 0.2, and when we have 2 here, so x1 and y is 2, so it is here for example. So for example it can be 0.5, and when we have 2 here and 1 here, so it can be 0.3 for example, and 2 here and 2 here, it must be 0 because the sum here is 1, so the sum of all of this will be 1. So it is easy for us now to read the PMF from this tabular. For example, when we say that P of 1 1 is equals 1 here and 1 here, so 0.2, and P of 1 2 is equals x1 and y2 is 0.5, and P of 2 1 is equals 0.3, and P of 2 2 is equals 0. And we'll define also the joint cumulative distribution function, or the joint CDF. The joint CDF of a random variable x and y is defined by FAB equals px less than or equals to a, y less than or equals to b, and it can be expressed for example like that. When we have continuous random variables, it will be integral from negative infinity to a and integral from negative infinity to b of the marginal fxy of x y dx dy. And in the case of discrete random variables, it will be summation of all x less than or equals to a and all y less than or equals to b, it is a, of p x y. We define the marginal probabilities when we are interested in probability statement of one random variable, and we are not interested in the probability of the other random variable. And the PDF, or the marginal PDF of a random variable x, is noted by fxx and is defined by the integration of the joint PDF of x and y, and we integrate for the variable y, so it will be dy and y here from negative infinity to infinity, and vice versa for the variable y. For example, if we want the marginal PDF of y, it will be fy of y, and we'll integrate the joint PDF with respect to the variable x. And we can define the marginal distribution of x by the fx of a equals limit of b goes to infinity of ab. So in this case the fx of a will be equals the integral from negative infinity to a, and the integral from negative infinity to infinity of fx y of x y dx dy. And also for y we can just change here b with a, and here d, here we must use dx and dy, and we just change here a by b.